What else is different is the sampling system we use. We don't use a size-selective sampler like a 37 millimeter filter, where the entrance velocity of the air is 250 linear feet per minute. That's not what the flow is in the room. That's artificial data. And if you increase the flow rate to 4 liters a minute, it's 500 linear feet per minute. So you can't improve your sensitivity because you're disturbing the environment. So we use and if you use the IOM, remember your pump, if you ever measure the duty cycle on your pump with a glass membrane filter, which is what's typically used for lactose, the flow rate is fluctuating between 1 and 3 liters a minute, many times a minute, because of the upgrading of the valves. Okay. So you really aren't doing consistent size monitoring or size selective monitoring with any of these devices. It's a compromise. We use a 25 millimeter conductive towel cassette oriented vertically so that falling dust can fall into it. So we will catch both dust that's falling as well as dust that's flowing past the cassette at approximately 4 linear feet per minute, which is about what's happening in a room that has no ventilation. So we're trying to minimize the bias due to particle size selective sampling. So here's how we create the array. We treated the filter dryer and the glove box as two separate devices. The filter dryer is a cylinder. So we selected several volumes inside the filter dryer, and if you take these areas I've shown here and project them into the center, like in the top here, we have a laser pointer. If you look at this, this is what we did inside. We split each of these 3 sections into 3 equal volume areas. And then we subtend them 1 volume outwards outside the shell. So we now have created, as well as putting an extension above and below the device. So now we've got a shell around the hardware. That should be our homogeneous shell if there is no release. Number the cells, and then using a random number generator, select 5 consecutive locations. And we turned out with 3, 4, 16, 17, and 18. It's random. There was no bias on what we did. And around the glove box, which was a diagonal front, it was a little more difficult, but you can see what we did. And we ended up with 1, 7, 15, 22, and 21 were the random locations around the glove box. The beauty of this is, if we didn't see any discrimination in the data that we got around the filter dryer or around the glove box, we now have 10 samples per study, plus a fugitive release by the agitator seal. If that matched the rest of the data, we could pull that too. So we improved our confidence interval in the data significantly. We were about 98% confident by the time we finished a couple of studies. We lost the first one, as you will see. So that's how we got out of the bias. And here's what it looks like. I don't like battery-operated pumps. We use a distributed manifold using regular plumbing pipe, PVC fittings, elbows, T's, to locate our samples in a rigid framework around the hardware. So here's a sample right here. There's one here. There's one here. That's a rubber stopper that contains a millipore cassette adapter, which has the standard number 2 taper that fits your cassette. And on the bottom of it is a critical orifice, 2 liters per minute critical orifice. We have to machine these with a Dremel to get them to be a nice finish and matched, because they're not very well matched when they come. There are rough edges, and it's not a true critical orifice, because what they do is they take a blunt nose drill and drill a hole until they pop out the other side, and then they determine what the size is. So we have to clean it up to get the knife edge. Of course, if you're running with a pressure differential of pressure, inlet and outlet pressure of 0.52 difference, then you're going to run a pretty much a stable critical condition. As a matter of fact, it's more reliable than your calibrator. More precise and more reliable. And since these are all hooked up to one pump, one vacuum pump, that's pulling, we traditionally use minus 19 inches of mercury, which I don't know what the conversion is, but that's pretty significant vacuum. You've got a substantial vacuum ballast around all of these, and even if you lose one of these samples, because of a problem. Everything will balance, because on the pump there is a vacuum release that maintains that negative pressure. So what you see here is the array around the body of the vessel and the array around the glove box part with the split butterfly valve here in the collection device. A little more close-up of the lure adapter. That's the one around the agitator bearing, by the way. And then is our SMEPAC method using battery-operated pumps. These are some samples they put around for fugitive emissions, as well as the area samples they put in the room. One by the make and break connection where the alpha-beta flange is. General picture of it. And there's the room. Extruded aluminium, 12 foot high, 8 foot by 8 foot wide, so we know the volume of the space. Roll the equipment in, charge the equipment, roll it in, roll the walls down, isolate it, run a background. We run every location that we're going to sample as backgrounds, not one. Because there's enough variability in a room that may have been exposed to lactose from a previous study. You want to be sure that you know what the background is. The board-headed guy's knee. There's the pump. There's the vacuum brake. And you can see this is a field validation spike. I don't know if you do this. What we do is we create a spike sample. The lab provides a sample spike with a low concentration of lactose or naproxen or whatever we're using on the media, and we run it side by side with a blank that's being just pulling ambient air. Because we want to be sure that during our handling and our shipping and our sampling, we haven't adulterated or biased our assay. Saved me millions of dollars over the past. There's the operator actually pursuing it. There's our industrial hygienist in there observing what's going on. I'll let you know the secret right now. Look at this. We didn't quite follow all of the, what was at that time, SMEPAC guidance. See where his sampling cassette is, right next to the collar of his shirt, right below his hair? He was shedding material from himself during the study. And the data shows that very clearly. There's the whole setup. We did the background samples for 3 hours. We went in, we did the operation for 3 hours. We took the filter dryer out. We recharged it. We put it back in. We did backgrounds for 3 hours, sample for 3 hours, took it out, recharged it, put it back in. And here's what the area background data look like in micrograms per cubic meter. These are the SMEPAC equivalent data points. Go to bottom plate, sample point, all area samples here. This is some scatter, but we had a background, there's no question.